Good morning, all of you. Welcome back to the class. I'm sure now you are feeling much more confident with the linked list programming. In the last class, we have discussed the programming related to linked stat and polynomial addition using linked list. So just to have a repetition, and those who had some doubts, they could see the implementation related to the corresponding linked polynomial logic I'm showing you for those who could not complete well. I hope with the partial code you could have done easily, but fine. If anybody needs any help via this code, it could be just demonstrated. So the same thing, just we have done creation using a double star or node return start, whatever you use, rest code remaining same, nothing big changing. The only thing is whenever exponent is 1, I'll be returning. Otherwise, code is simple. So I have initially first node created for the first time when exponent was -1. I initially failed. Initially itself, I have taken start equal to start equal to null. So that will ensure empty polynomial or empty linked list also to be generated correctly. And finally, rest everything here, wherever I have start, now I'll use start, and then I will be reading the coefficient, storing into this, and then finally doing the same process here. Here, both way you could do, either you have a separate variable, coefficient 1, and then stored, or you can directly read using ampersand, and then you can have the parameters to ensure that proper associativity and precedence of operators takes place. So priority based, I have just put this, and otherwise you could have also done like this also, and then storing this into the other variable. One and the same thing. And then finally list over. Traversal, I have just revised the traversal, that some beautification done, otherwise simply also. So I'm trying to display the polynomial by using 5x power symbol and 6, etc., etc. Like that. So here comes add poly. We have already discussed. First thing is if both polynomials are null, obviously return simply null. So that can be a special condition added. Otherwise, I say initially poly 3 is null, temp 3 is also null. Whenever temp 3 or poly 3 get generated, obviously I will have the corresponding logic added. So if, as long as both lists are non-empty, exponent comparison, if coefficient is non-zero, that will be stored. Otherwise, if coefficient is 0, that will be ignored. The additional thing is if initially list is empty and this is becoming first node, I will have this kind of a logic. Otherwise, temp 3 is always going to point to the next, and otherwise this linking is going to happen in that. So if the poly 3 was null, this will be there. Otherwise, linking will happen. Temp 3 always updated, temp 1 and temp 2 updated. If the coefficient was not null, temp 3 will be used. Otherwise, temp 1 and temp. Similarly, for this exponent being greater, again, if needed here, again, similarly here also another if needed, else normal process. Similarly, see you come back, copying the remaining elements. Again, this if will be needed. So you can see a lot of times the same if is needed. You could think of making a solution that initially I will take one extra node, but normally we should always have extra node malloc only when it is desirable. So that's not an ideal solution. But yes, that similar logic is used when we use the concept of header node. So we will discuss in the next class header node concept that will solve all these problems and indirectly tell you that yes, it is possible to have all these things done via header node, and that will simplify, and lot of if, etc., or special conditions will get easily handled via that. So that makes the code simpler. Otherwise, this way also we can do. Similarly, so if I have the same coding done and accordingly greater, lesser, and etc., and then remaining elements being copied. Then from the main I'm calling. So I'm just displaying it. For example, if I'm saying that, yes, this is about a program. So my execution, I can show you how it will happen. So just let me have the corresponding execution taking place. And here, so I'll just give the data, and first polynomial given, second polynomial given. I've just done copy paste, although specifically you can go. And this is the output you will get. So you can say this is the way I am displaying the output, and I'm accordingly having the output displayed in this first polynomial plus second polynomial represented in a power symbol, etc., and then showing the total addition. Just a sample addition, but otherwise all test cases which you have used earlier, you can still use again, and the same will be still applicable in all situations. So having said that, now let's resume to next discussions and some important new additional knowledge to be created for linked list. So now I'm sure all of you are much more confident and able to do basic programming. Then we go for some more operations on the linked list, which are relatively not as simple as they were till now. All these program operations which we have discussed till now, insertion, deletion, etc., they worked easily even if the code becomes lengthy. One operation which we are going to see today is called reversal of a linked list. Now, that is what is relatively somewhat more standard algorithm, and we are going to see techniques, but it's not as straightforward as we have been doing till now. So now we talk of that because your basic understanding is much better. So reversal of a linked list primarily means if I have a list, singly linked list for the time being, I will say singly linked list, and then we will also talk of the same thing to be done for a doubly linked list. So if my singly linked list has, let's say 1, 2, 3, 4, 5, obviously I mean that initially this list was like this. So initially my traversal of this will display 1, 2, 3, 4, 5. Now I want, if I have this list, the list should be ideally in the order of 5, 4, 3, 2, 1. Yes, some of you could think a simplest and easiest ways of doing this. Yes, easiest way. Maybe you will say, I will do the traversal and use a stack, keep on storing into the stack, and then pop and display. That will effectively mean 1, 2, 3, 4, 5 will be there, and I will be doing that. Yes, that could be easiest way. Whether good or not, we have to see. Similarly, you could think of primarily having some array, etc., storing all values into the array and then displaying the reversed array, or displaying array through reverse. So initially storing in array and then the array being stored, traversed in the reverse order. So store in array and then display. Again, not a good way, but yes, can be easiest way. So I'll say all these are not good ways of doing because aim is not just to display. Never think that the purpose is just to display. No, it is never. Reversal means it's an operation. Reversal primarily means that initially you were calling a traverse function with the start. Now you were getting output as 1, 2, 3, 4, 5. After reversal, the same traverse function called should display the reversed output. So I'll say now if I call traverse with the same start again, that should display 5, 4, 3, 2, 1. That effectively means my list should get reversed physically. It effectively means I should have my list stored like this only, not anything else. So this should become the list. That also means no extra malloc to be done, no extra list to be created, no extra malloc to be done at all. Effectively, relinking among nodes must be done. That is the primary purpose of this. So, see, remember, if I say I have said reverse a list, that can be one. Another way could be create a new reversed list. But that means an additional list created. Then you will need malloc, etc. Original list will be undisturbed in this case. So that can be another way of doing. We are not targeting that. We are saying original list to be reversed. So for all purposes, the original nodes and original list itself should be reversed. And same traverse function which you were using earlier with the reversed, the same traverse function to be used. No traverse logic to be changed. no create to be changed. Everything same, only you will have a reverse function. So this is what I need. Obviously, it means the start pointer changes. So start changes will obviously mean that I have to either make it as a node star reverse, and then obviously node star start needed to be passed, but it should return the reversed list. Or obviously I could have a double star used, so then it will mean void reverse, but then a node double star star. So both alternates now you know well, so you can practice this also. So either let's do anyone, say first method, second method. So we will think of doing anyone, doesn't matter. Syntax is similar, so logic will remain similar. Now, I'm giving you a few minutes to think what to do, how to do this. Primarily, what it will mean, the basic concept is going to be linking to be changed. So initially, if I had start here, obviously one change will be start will reach here. Secondly, what I say, earlier you had linked like this. Now I will say, no, don't keep links like this. I will say, ideally, this link should get removed and it should become null. Then similarly, this link should point to this, and the same process with everyone. Except first node, when it was going to become null, I effectively mean link to be reversed and going like this. This can be done with any number of nodes, and when you reach to the last node, effectively work will be over. So what I need is effectively linking to go in this form. But remember, because we are going to lose this link, so this next time I have to start with the 3 also to be done. So I should properly maintain the pointers or next pointer stored somewhere, etc., etc. Think of the solution, think of the repetition, repetitive steps, and try to write a loop. Looping and logic. So design that. I'm sure I'm giving you a few minutes pause and you can try that, and I will be again resuming with the discussion, but just give a thought to this. How will you do? What logic you need to write? What initially you need to write? What while loop you need to write? Within while loop, what you need to do? And how to ensure for most of the cases. So first target should be for your 80-90% cases, it should work. That will simply mean that your list has 3, 4, 5, 6, 3, 4, 10 elements. List is not a special situation. So list of 3, 4, 10 nodes exist. For that, your code should work. Then we can think of list having only 1 node, 2 node, or 0 nodes, etc. But this 90% times, if you are able to think, rest code will be simple. So those who want to try, I must say that yes, do that. And those who are ready, they can see with the video. Otherwise, you can pause the video and then you will be able to see after you are ready. So once you resume, now I will be starting after a few seconds pause. Yeah, so now I say, yes, might be, probably you are ready and you have tried. So what is basic step which I need to repeat? Effectively, what I need is that I am on some node, current node. Let's say this is my 2. So I need some current node here. And I want to say this current node should be linked with some previous node. That is a primary step. And the process to be repeated every time. So previous and current to be updated and repeated every time. But obviously you can see, if you want to shift to 3 and then 3 to be linked to 2, you should have got some way to reach to this node. If you have changed this link, you have lost this link. So that means before that, you should have stored this link or this node somewhere. Maybe I'll say next or next node. In a singly linked list, we have used the word link for the structure. So next word you can use. If you are using doubly linked list, next word we have already used. So we should not use a variable name as a next again, because that is normally confusing. So I'll say, yes, I will effectively use the three, and these 3 pointers ultimately to be shifted forward, and then keep on repeating. So primarily, this is my logic. Explaining this, now probably again I will say, try to write your complete code, and then you should be almost ready to have the code ready. For 90% cases, 80% cases now. So again, give a pause, try that. Once you are ready, you can come back and resume the video. So after a few seconds pause, 5 seconds pause, I will be resuming. Yeah, so I'm sure now most of you have done some coding, but let's start. So I'll say, obviously, let's implement it by writing node star, reverse, and node star star. That will obviously mean return start statement, or that has to be. Maybe I'll just use a variable head for a change, that not every time use word start, because primary your formal parameters or within the function your variable name can be different. From main you could still pass start. So what I need, obviously I need first situation we will handle in a separate manner, or any special conditions we can handle later. Assuming that there are 3, 4, 5 nodes, what I need always my previous to be on the start node. That will mean my previous will be the first node. So that is equal to head. Current I need to be the next node. Current equal to what? Current equal to head arrow next or previous arrow next link. Link variable we have used in the singly linked list, if you remember. Then what next? Maybe I can think of using next word also, and next also to be written. That can be one way, but I'm not writing because we will have some discussions over that. But yes, if you have done that, still. Then obviously I need a loop. So I'll have some while loop. And then within loop, what I need to do. Primarily every time what I need is head link to be changed. And first thing more, this link also needs to be made as null. This step also you have to do always. So if the list had some elements, obviously this needed. So this also I can write maybe head arrow link equal to null. Head is initially the first node. So this statement you can have. So this is my head node or previous node also. So any statement you write, but this becomes the reversed list and stopping point, so that your traverse logic will not fail. So as soon as you did this, effectively means you lost this link. This link lost, it becomes null. But not a problem, because current pointer is already stored. So if you have changed your link, earlier this link was 1 to 2. I'll say, just let me show in this way. So earlier you have here head. You have got your previous also here. This is 1. This is 2. As soon as you write head arrow link equal to null, this effectively means this link lost. Link lost means I will not be able to reach to 2, but before that statement, I have already stored current. So this list is still perfectly accessible via current. Hence, this does not create a problem because I have already done this statement before null. So now this I need some loop. What I need internally? Internally, every time I need is effectively to break this and link like this. That effectively means every time I need current arrow link to be equal to previous. But as soon as I change link, I lost the next node. So I needed next pointer. I could have done that inside, outside the loop also here. I say there is no difference. I can do the same thing here also. So I can say next node I will be storing here saying current arrow link. You might have done it outside, still one and the same thing, but one advantage I will get by putting it here. So this becomes the next node. As before I update my link, I have stored that. Still perfect. This. And then what I need? Shifting of the pointers. You might, so shifting. Which pointer to shift first? Here the order is important. You can't simply shift next pointer first, because if you shift next, you will lose a pointer to 3. So next will be the last pointer to be updated. Similarly, if you shift current, maybe you will use a pointer to the 2 also. Previous pointer or one node is no longer needed. That's a guarantee. So previous pointer will be the first to shift. Previous I can bring to point to current node. So it means this pointer can come here. And because I don't need any pointer now to point to 1, so previous is the first pointer to shift. Current can be again shifted, because for next iteration, current needs to go to next. So my current comes here. And then next also you could probably think to shift to next, but I'll say that is already being done here. So in a next iteration, this next will get automatically shift, and this other two have been shifted here. And effectively, this is the process. Of course, if you write again next, still not a problem, but you probably not need it. You can see when to stop. So here comes the difference. Earlier, you might have stopped, or you might have written the code by saying while next not equal to null. I'll say that code will mean if you stop, for example, you have reached to 4, all linking done like this, you have currently node as 4, next node as 5. If you are at next node this, you will say, okay, 4's link updated, perfect. After that, you have all shifting done. So if you shift next also, you will be checking condition on next basis. I say I can improve that further by saying simply what should be the condition. Whenever I am inside the loop, current links get updated. So as long as current node's link is unupdated, I have to repeat. Later, my current shifts here. For the time being, this is also here. Previous has shifted here. Previous current, current next. Now I go back. This link has not been done. That means loop should still repeat. If repeat, I should say current has to be checked while current not equal to null. Current is currently to the last node. So current null means I will go here. Next will be current arrow link. So next will become null. Next means this. That is effectively null. Current is here. Current next equal to this, done. Current arrow link equal to previous. This link done like this, perfect. Current link updated, and then previous shifted, current shifted, current becomes null. You come here and stop the loop. And that is what I needed. So this is how you will decide what condition should I put. And based on that, the code becomes very simple, except one change, that I have not returned the updated pointer. Once I am out of the loop, what should I return? What should I return? Updated start. Maybe even I can write here statement, if need be, start equal to this, start equal to something, whichever was the last node. Current is not the last node because current is null. Next to that is obviously already null, not to top. So previous is the node which is the last node now, and that becomes a start. If you want, you can write before this also start equal to previous, and then you say return start, effectively updated start, or sorry, I'll say head now. we have used the word head. So head equal to previous, and then you could say return head. It is one and the same thing, just showing that I have updated head. This also means updated head, because in main, you are guaranteedly going to write start equal to reverse and of course start. So this updated value must be returned, and even if you don't write head equal to previous, return statement will update inside the main. So this is the call. So this is how it will work. Having said that, I think this is simple and you can easily do without much of a problem. Similarly, you could have used double star, and that also could have been okay. Double star and use of ampersand, that also can be second solution. Second way of doing the same thing. So you could do anything. But I say this is a simply iterative process and easy, not difficult. And you can do that. Of course, the code is almost perfect. For 90% cases, probably it works. For remaining special conditions, for example, list of 1 nodes. Only 1 node exists. For example, I have, let's say, 25 only. This is a start, and 25's arrow next is null. My reversed list will also mean the same thing. Reversed will still mean start will remain here, and you will still have the same node and still null, because 1 node means perfect. Will my code work for that? Previous equal to head, so previous points here, perfect, not an issue at all. Current equal to head arrow link, so my current becomes null, but the statement works. Perfect. Head arrow link equal to null. This is my head, so I say in this code this is head. Head arrow link to be equal to null, already null. Reiterated this statement. Then I say while current not equal to null. Current is already null, while loop terminates, brings me out. And here you come and then you say return previous. Previous is already to this node, return previous, that means still perfectly fine. Not an issue. Empty list. Second special situation. So special condition 1, special condition 2. Empty list. I say in case of empty list also code should not crash. Head is null, previous is equal to head, perfect. Current equal to head arrow link. Head is null. Via null, if you access this statement, you get trapped into crashing of the code. So this will not work. So I can probably think of just simply writing if head equal to null, you can have a special if for that. What I should do? Return head or return null, whatever you say is perfect. So you can have an extra condition for special situation 2. Special situation 1 was being perfectly handled without much of a problem. So this will become a special condition 2. So you could write if head equal to null, then you are going to return null because list is already empty, or return head, one and the same thing. Else your rest of the code will work without a difficulty. So having said that, this reversal works without much of a problem. Going further, let's see now. The same thing we have done, and for doubly linked list, how to reverse. I say for doubly linked list, things are still easier than that. Even easier than a singly linked list reverse. Because here the backward traversal and from last node to the previous node coming was also possible. So you could easily say that I will go via this or like this. Earlier you couldn't think that I have 1, I am on 5. Maybe you could think, okay, I will have from this side something done from this side. But from 5, you could not come back in case of a singly linked list. You have no way to come back to the previous node without linking. Your linking was like this, and you wanted to come to the previous node, you could not come once you reached to 5. In doubly linked list, it will be possible. Even if you are at node 5 and you want to come to 4, it will be possible. But again, remember, reversal means not just display. Otherwise, you could say reversal will mean traverse backward. You have already written that function. Traverse back will display effectively 5, 4, 3, 2, 1. But I say no, that's not what you have to do. Reversal of the linked list again means original list to be reversed. That is what I am trying to do. Not to create a new reversed list, not to do anything additional. I want original linked list to be reversed. Means what? Initially, if you have a traverse forward with the start, that must display 1, 2, 3, 4, 5, but traverse back must display the reversed data with the same variable start. That will display 5, 4, 3, 2, 1 initially. After reversal, the things must change. After reversal, the same call should display the different output. Traverse forward with the start itself must display 5, 4, 3, 2, 1. And a traverse back must display the reversed value now. So traverse back with the start should now display 1, 2, 3, 4, 5. Just 10 minutes more. Yeah. So that will be what I need here to do. This effectively means after reversal, same functions should be, traversal should be able to display. Again, it means my list primarily should get stored as a 5, forward pointer here, back pointer here. 4, forward pointer this, backward pointer this. 3, forward like this. 2, forward, backward like this. 1, forward null, and this backward was null. So this should become now the updated list, and this should be the start after reversal. Same start must reach to this particular point. If I want this, effectively means my original list to be reversed. Only then this all will happen. But I say now, this is much more easier. In fact, I can think of 3 solutions. Probably you can think of more than that. First solution. Yeah, for doubly linked list reversal, there could be many ways. And I'm going to discuss some of these. First solution, I'll say reversal of values, reversal via values exchange. In array also, probably you have done that. Value swap. What does that mean? I mean, initially I had list 1, 2, linked like this, 3, 4, 5. Here was a start. Of course, a start will go to the last node. That indirectly means I will swap these 2 values. Here I will bring 5. Here I will bring 1. And it is possible by bringing your last pointer and taking your first pointer. So this is your first node. This is your last node. And via traversing, you can reach to the last pointer. And then these values you can interchange. But the advantage is after that, you can shift first to the next node and last to the previous node. So here you had 4. So your first node or this side front node can shift this side, and your last node or previous node can shift this. So I'll say swapping of what? swapping of value of first and last node. Similarly, repeat this second and second last node, third and third last node, and keep on repeating this. So one by one, and because now it is possible, in single linked list you could not come back, so this solution didn't work there. So you can effectively have like this. This becomes a simple solution. Of course, you can easily implement. I'm not going to write the code for that. Solution 2. The way we said is swap the values. I can think of doing pointer-based swapping. Swap pointers with some careful logic and special cases, etc. to be handled. But what I mean is, this was 1, this was 2, this was 3, and so and so. Initially, this is my forward pointer, or I will say this is my next pointer, and this is my previous pointer. I can think of a saying that now I can have reverse. This becomes my next pointer, and this becomes previous pointer. So these two have been exchanged or swapped. So if I say I have already swapped these, then after this swap, because above side I am always showing the next pointer, so it is effectively swapping physically. That will mean 1 is here, 2 is here, same process repeated here. My above pointer is actually always the next pointer, and downside shown is always the previous pointer or back pointer. I think we used the word back earlier, so I will say this word was back, and this is my next pointer. So if I change everywhere and bring my start here, things become same. Start next traversal is effectively traverse forward, and a traverse forward will effectively mean 5, then 4, then 3, then 2, then 1. And similarly, if I have 5 here, this is my forward pointer or next pointer. This is my back pointer. Here I have 4. My start is already here. So my start is already here. From start here onwards, next forward traversal went 5, 4, 3, 2, 1. And traverse back will mean what? Traverse back, effectively, if you remember, how did you do, was simply that, just let me have ink. So traverse back effectively meant that you are going to now first reach to the last node. From start, next, you will reach to 1. And from 1, you will traverse. So you will reach to 1. And then what you will do? Then you will follow your back pointer. So back pointer is effectively, now this is your back pointer. So back pointer is down 1. So from back, follow back pointer and display. That will effectively mean it will display 1, 2, 3, 4, 5. Start is here. So that could be perfect second solution. So this will mean solution 2 effectively meant swap pointers of effectively mean next and back. And with, of course, null pointer to be taken care wherever I have to be. Null pointers, special situation, null to be handled for the this and etc. And finally, start to be updated and returned. In case of a value case, start was not being changed, start always remained to the first node, and in this case, start will change. That can be solution 2. Solution 3. The way we did with linked list. Effectively same logic to be used and same process you could go. More or less, these two are similar, but the process, the methodology is different. In case of solution 2, I'm swapping. Here I'm not swapping. Here I will say this is node 1. This is node 2. So I will say this forward to be linked like this. This next to be linked like this. Come to the next node. Forward pointer to be linked like this. Next to be linked like this. And so, and start coming to the final node. So solution 3 means effectively do like this. So homework for today. First, reverse a singly linked list. Of course, it is an iterative logic. Why I'm writing iterative? Because after this discussion, we will talk of recursive solution also. And then say reverse a doubly linked list using any one solution. Using solution 1 or solution 2 or both, if you can try, that will be best. But at least one you must do. Then, now, some more concepts, relatively difficult, not as simple as till now we discussed. So those who don't understand this need not bother. This is a relatively difficult concept. First thing, the singly linked list reversal logic which we have written, code can be smaller and still similar. Even one if can also be removed, which we have used as a special case. That also can be removed, and by doing some smarter way of coding, that can be also handled via while loop itself. But I'm not going to explain that. Read the book and see the book's code and versus this. Book mean the Horowitz and Sani book, same, which book you have been referring all now. So read from the book also, and then you will understand. But that's not a difficulty because code is almost similar. But yes, you will understand some smarter way of writing that. The concept, difficult concept, which I'm going to do is recursive solutions. I say reversal of all solutions which we have discussed can be recursive also. For example, singly linked list reversal. First, let's see how to do that recursive. This will have alternates, two alternates, alternate 1 and alternate 2. Alternate 1 means I have, let's say, this node, rest list is like this, and so and so. So I say, effectively what I will do is, every time I will break this link, have this linking done as step 1, this linking done, and recursively step 2. Of course, that will mean this pointer stored, and via that, this link will be reversed. So I say every time I will do linking of my current node with the previous. So this is my reversed list. So you will need accordingly pointer to the start of the reversed list. And this is a remaining list. You will need a pointer to the start of the remaining list. And every time your remaining list's first node arrow link to be given to start of reversed link, start of reversed list. Because reversed list will always have this as a start, later next time this as a start, and finally your reversed list will have updated start. So your remaining list's first node's arrow link to be assigned this link, and then finally again a recursive call to happen. So update your start of reversed list. That will be step 3. So this was effectively happening, and then finally call recursion with the remaining list with the next revised node, next node to what has been changed. So that can be one way. Not easy, but yes, those who want to try, just I have given hint, you can try and see. You have to take care that updated start must reach back to the main. And that indirectly means that either you will use a double star start or you will have a return pointer. But whenever you use a return pointer, every recursive call has to handle that. Having said that, I'll say another way, alternate true. Alternate true is again similar, but done in a slightly different manner. So alternate true, I am going to now demonstrate. Alternate true says slightly different way of doing. I say initially this is 1, this is a 2, and so and so. I say I will reach up to the last node first. Once I have reached to 5, I will say first I will assume this is my reversed list. So my reversed list is last but one, all nodes there. This is my start of the reversed list. And then I will say, after this, I'm going to change the link of the last node with the reversed list. So I effectively say last arrow link to be equal to start of reversed list. And that's it. And then update start and over. And return also, of course. But it means your recursion is before this linking done. Recursive call will happen before till you don't reach to the last node, and you are assuming this list has been reversed. So what I'm assuming is when I reach to 5, my recursion has been called. Recursion call means once this recursion is over, effectively what it means is list has been updated like this. Start has reached here, and now you are on the last node. So this via recursion done. This is step 1. Then I say this pointer to be linked, that will become step 2. Last arrow link to be updated. And then step 3 will be your upstart will become equal to the last. So via recursion, updated start was returned, that has been assigned to this, and your start has been changed. And of course, the rest you have to take care. So this recursion, of course, cannot be infinite. So based on some condition, till you don't reach to the last node, you will call recursively. Once recursion over, you assume this has been over, and after that, this step will do the link. So difference here being the linking we are doing in this order. This is the sequence of linking done in the reverse direction from the backwards. in alternate one, we have linked them from the first node onwards. So in this, linking is from the reverse, from the last node backward. So call of the recursion in this case will be firstly done, and after that we will be doing. In that case, first link will be updated, then recursive call will happen. Of course, in both cases, you should be able to send the updated start always. Updated start must go back to the main. In this case, the only one point which you might come to your mind is that first logic will internally traverse by using these links up to forward, up to the last node, and then again come backwards by going this. So effectively, it will have effectively a kind of a twice traversal, because first we will do nothing but just keep on going forward, and then coming backward via linking. So internally, the recursion will work like this. So you must be able to visualize recursions working. That will help you in making better clarity of your recursion. So recursions working, if you are able to visualize how it really happening internally once you have made a call somewhere, if you are able to do that, this will help you in better learning. So try to develop that realization or virtual visualization, then you will be able to do recursion more confidently. Similarly, what I said for the doubly linked list, your solution 1 can be recursive. Solution 2 can be recursive. And of course, solution 3, like we have done for the singly linked list, this also can be recursive. So you can try recursive also if you wish. Those who are good programmers, they can definitely attempt this and make sure that you get something working. Once 90% code works, 90% cases handled, then think of special or exceptional cases. In recursion also, you have to take care of that. So, like one node, empty list, all those cases, later you can think to solve by writing the proper code. So those who are good programmer, they can look in this. Otherwise, simple iterative solutions without much complexity are possible. With this, I'll stop. Bye-bye. All the best to all of you and enjoy.